Okay, good afternoon, everyone. My name is Nikolay Piskun, and I'm software architect at TotalView, which is now belong to Perforce Software, and I'll be also talking about Debugger. And I'm working for TotalView Debugger for a number of years already, and our company started as a small high-performance company, which is only focusing on debugger, and they started without me like 40 years ago, maybe more. And we started supporting supercomputers, but then we go down, and now we are basically debugger for starting from supercomputer down to laptops. So today I will be mostly focusing on HPC debugging and dynamic analysis with TotalView, but just to mention that dynamic analysis, I mean just usual debuggers. There is also static code debuggers, and Perforce owns actually a very nice company, Clockworks, which only specializes in static analysis tool. So you can run your code and it will generate like thousands of suggestions. So it's very advanced tool. So if you want, you can try on our Perforce site. And actually, before I go, how many people know about TotalView? And how many people it's first time they hear? Good, fair amount. Okay, so I'll be talking about some advanced feature, but also about some basic one. And since it's workshop, I will also follow similar pattern like my previous speaker. And we'll also have, after that, some head-ons. So let's start with just general, what is TotalView? And usually we start with TotalView is HPC debugger with comprehensive multi-thread, multi-dynamic support, which doing hybrid MPI open MP applications. But what I want to say is that actually it's a very good serial debugger tool. And it have advanced C, C++, and Fortran support. And actually it started as Fortran compiler, so now it's C, C++. And lately we also added mixed Python, C, C++ support. So if you have your Python calls, Python will call C, C++ libraries, and it's glued together. You can debug it in one session. Also, we develop our own memory debugging capabilities. So I don't have time to go deeply into memory debugging, but we have a video so you can see on our website. And I'll just mention that we have automatic leak detections, bounce overrides, all this memory stuff. And it's all on the fly. So you can stop your session at any point, run memory debugging, find your actually problems, fix them, and go forward. We also support batch and unattended debugging, and so you can set up your batch job, and then you can look on the results and see where your problems and analyze that. We support also Apple, Unix, and Linux operating systems, and you can actually debug on Apple, which is quite a challenge, if you know what I'm talking about. And so just some side talk. I'm also a developer for a while, and one of my tasks is finding bugs and ports and doing ports. So I really like examples that TotalView gives you. And I know about GDB, obviously. I was a student too, so I use GDB there. But once I moved to real debuggers, and I'm not talking only about TotalView, but about different real debuggers, and it's really save your time. So this is the main advantage. The main advantage of GDT obviously is free. So, but since some of you are students, for you TotalView is also free. So I'll mention that. We also support different applications like MPI, OpenMP. So back to presentation, and platforms usually was the whole slide, but now they kind of a little shrink to major ones. Intel, NVIDIA, ARM, AMD cover almost everything, and Hewlett-Packard's also combine and previously Cray and Sun. So we cross product, so we try to support all partners, and including actually all partners, except we don't have a lot of products on Windows for TotalView. But Perforce do support some Windows product. So talking about debuggers, so this is more than a tool to find bugs. So it can like speaker before me mentioned, it helps you understand your complex code because you actually see your code and you see how the program flow goes from one point in your execution to another. And also using debugger, you can change this execution, so you're kind of steering in the way how you want your program to behave. You can change variables, you can jump in your code and continue to any point multiple times. You can also collaborate with team members, and one of the example, you can save TotalView session and you can load it again and compare with previous runs. So you can done with our technology, which is called replay and reverse debugging. All of that allow you to improve code quality and shorten development time. And this is basically the most important. So especially if you have allocation on supercomputer and you're limited time, you really want to improve your efficiency, shorten, and get your product ready. So now for this is a little bit about top level features. Now I would like to go to more details. So let's talk about totally default views. And so probably a lot of you is new to debugger. So this is a new interface. So we also have a classic interface, which is a little, probably looking a little more old, but on the other hand, it's more efficient right now. So we are moving to new interface, but sometimes it's a little slow. But for, I think, all our purposes, I will be mostly talking about new interface. So the main window here, if you're talking about MPI, is process readiness control view on the, I don't know if you can show you here, on the left side. And this is where you control your application from a processor point of view. So there's all threads and processors aggregated here, and you can switch between them and focus on particular thread. In the middle, there is a source view, which is actually where all your debugging happens. And on the right, there is call stack and variables, local variables, and all other functional panes. So process and thread view actually allow you to, like it's here, to select processes and thread attribute, and you can rearrange them. You can see how many processes are in particular line, and you can filter out everything. So this is your top control level for MPI process. And once you select particular line here, you can focus that on a source pane, which is where your actual debugging happens. You can set breakpoints here, you can move forward, and if you're using replay, backwards. And you can also click on particular, this is highlighted very nicely, so you can select function and dive and go deeper to investigate. And another point of dimensional control is call stack view, where you can, if you stop deep inside your function and there is multiple stacks, you can switch source pane very easily just clicking on different stacks here. And for each particular stack, there is corresponding local variables pane. Any questions so far? So if you have a question, you can write it down and ask later, or just stop and ask questions. Action point view have all action points, like it said, but in addition to usual ones that probably everyone know, breakpoints and watch points. And again, watch points you're watching memory, and breakpoint you're watching source code. We also have barrier points, which allow you to control MPI applications, so you can stop at particular point and then go forwards, like synchronization points. But there's also very nice evaluation points, which allow you to patch your code as you go. And this is one of my favorite features, because you can actually patch your code on the fly without recompilation. So in this example, you see line 54, you have a for loop, and I don't like this for loop, so I can write a code snippet, and I can substitute the code on line 54 till 59, and then just say, jump to 59. So basically, I erase code from 54 to 59 and put my code without recompilation. So if you have allocation, for example, it's very handy. You don't need to recompile anything. You just run it and test your code. You can also put this code inside expression window and just click evaluate. So you can evaluate this code on the fly. So this is one of the advanced features. And preferences. So if you really hate your light scheme, so you're really fond of dark scheme, we don't want to fight with you, you can switch to it like on the fly. I know a lot of people like dark scheme. Personally, I like light one, but I know some people really want to switch. That's why we put it here. Also, you can switch between different interfaces here, change font size, and there is also different preferences for search paths and remote connections. So far, so good. Okay, so some advanced debugging technologies that we can talk. And let me start with MPI, OpenMP, and GPU hybrid models. Okay, so thank you for image from US Department of Energy. They really spent a lot of time writing this down, and we just borrow it. There used to be time, long time ago, when there was two different models. One is MPI, and MPI is usually allow you to use parallelism in between compute nodes. So previously there was like cluster, and you have one processor per cluster, and you have MPI, and that's it. So you can increase your size of your cluster and use MPI to increase performance. There was also another kind of machines with shared memory, and that one used a lot of so-called processors or cores, but memory was shared. This is so-called single data multiple processes. With introduction of cores, these two models actually combined. And if you really want to extract the maximum performance, probably you already heard that, you need to combine multi-threading and multi-processing, because your process most likely have many cores and your cluster have many processors. So this is hybrid OpenMP MPI technology. And on top of that, everyone is talking about GPUs. So you have GPU on top of that. So how debugger can help you with that? So debugger can support all of that in one session, and this is a big draw, so it's simplicity. So you don't need to have learn multiple tools, or you don't need to learn multiple sessions and start multiple sessions. Everything is in one session, and you can switch between different processes and thread here. You can switch and go to GPU and and analyze variables there. There's a very nice video here, and throughout probably my presentation there's like links to videos, and so you can just go and watch it in your spare time. And I will move directly to CUDA debugging. That used to be the only GPU, but now we have also ROCm, and I will talk about that later. But starting with CUDA, because CUDA was first, obviously, and we were partnering with NVIDIA for a very long time, starting with the first GPU machine, Tesla, and we are supporting all current cards till Ampere and all latest SDK till 11. I don't list here before 9, but we actually support them too. We just don't test them anymore. We just upgrade everything to latest one. With GPU, we support unified memory, 64-bit CUDA programs, and we support multiple cards per node, and we can actually debug the whole cluster of GPUs. So this is some video that shows that actually we can have everything in one session. You can set a breakpoint which is unified. You can see variables, and we can also leverage CUDA memory memcheck, so you can stop with memory problems. And lately, just move forward. We added GPU status view, so you can see the all GPU threads in one pane, and you can see we can aggregate them and see how many warps are used. And probably I'll show you the demo, which will be easy to see. So this is as far as GPU. And when AMD ROCm came, so we decided to go the same direction. So we combine ROCm GPU debugging in one session with CPU. So you can start with CPU and as well as GPU. You can go in GPU, debug there, go out and continue debugging on your CPU and GPU in one. So TotalView ROCm support, it's obviously work in progress, as you heard from AMD. We're working very closely with them, and we are utilizing their API, but I should probably mention we don't use GDB, and TotalView has its own backend, so we always use our own backend. So we are probably a little further than GPU in some aspect because we just utilize API from AMD. So right now we unofficially support version ROCm 5.1, but I think with latest version we support 5.2, and that allows us to show variables, stop inside ROCm, and basically show almost the same data like for GPU, CUDA GPU. So I think we already saw in AMD there is special different flags that you need to use if you want to debug, and sometimes you need to be patient because this is work in progress, as I said. The difference with ROCm GPU from architectural view is probably very significant. So instead of warps and lanes as SAMs, you have agents and I cannot remember all of them, but yeah, there's difference like names. But from TotalView, it's the same software presentation. So you have negative numbers for each card, and we can show you whether it's active. For example, agent 3 is active, and actually we can show you agent. This information is, so we can extract all information about GPU. And agent 4 is idle in this case, so but it's loaded. And as similar to GPU control, we can control down to individual thread. You can change them and see different variables. And we can control logical one, 6-dimensional space, and 5-dimensional physical space. So here is agent, queue, dispatch, workgroups, and lane. So we can show you like dimensions of both of them. As I said, variable display will be available in 5.2. Actually, it's already 5.2. So it's slightly little older because we develop it in beta compilers, AFAR, and now we can support it with 5.1.1 actually. So if you want to debug with the released version of TotalView or with some future release, you need to add flag -ROCm, and right now default is no support, so you need to add this, but with upcoming release we will probably officially add it. So official support will be probably the end of the year. I'm not sure it will be in August release, but definitely in November. Okay, let's switch again to a little top level view, remote debugging. So you can probably know it's much easier to start and debug everything on your laptop and not go directly on supercomputer center. So TotalView, we have developed remote UI. So we combine efficiency of remote connection, and this is also some video how it works, but in a nutshell, we have TotalView UI on the remote machine, and remote machine can be Mac right now and Linux, and we will be adding Windows also shortly. And it doesn't matter what is client UI will be. So which client UI usually installed on front-end node, and it will connect through SSH to your laptop, and we can set up the whole SSH path. So most of the time you don't even need to type password, you can set it up, but if you need, we will ask you to passcode. And remote UI, so it's also UI, but like client UI, second part of UI, it will control everything on compute nodes. So it will start and run your job on your batch environment. And on your compute node, you can set up your reverse connection, and in batch node you can type TV connect, just append to your command, and this command basically remote UI in reverse will ask TotalView to connect, and as soon as your job is ready, as soon as you get a location, TotalView will connect to that automatically. Okay, so let's go and see some demo. If I have some luck, I probably can do it here in the local machine. Okay, so there's a multiple ways how you can work on supercomputer centers. So basically here it's my virtual machine on my laptop, and I will first connect to Theta. Okay, so I'm here right on the Theta, but probably I will probably not use it a lot, but usually you can go to this directly command line and you can submit your jobs, and then TotalView will connect to it. But let me first try something locally. So I have TotalView installed locally on my machine, and by the way, I think I put in examples, I put distribution installers for TotalView, so if you want, you can install it on your laptops. And right now, I don't know, maybe it will change later, you don't need a license to run a remote UI on your laptop if you're not debugging on your laptop. So if you only install TotalView to connect to Supercomputer Center, it's basically free for you. So I install it. Okay, so and let's talk more about TotalView. So first you see a start page, and there is different functionality of debuggers that you can use for any debugging session. You can debug a program, debug a parallel, attach to process, load core file, and as well. But in our case, I will go even down, and I want to launch remote debugger. So you can select from previously recorded ones, or you can create a new one here. So I pre-recorded it, and okay, let me actually. So there's two, yeah. Okay, let me go. No, not this one. This one. So there's two ways to do it. First, you need to basically provide a name, and then provide a path. And yeah, it's not very easily to see, but basically it's set Piskun at Theta, ALCF, NLL Gov, comma, and then Theta GPU SN1. So you can provide the whole path for SSH, how you want to connect. If it's less security than here, you can provide a key file, private key, and then you don't need to type password. And also required is TotalView remote installation directory. So I installed TotalView at rest 22 examples, and remote command is nothing here. So after I do that, I will just connect, and then I can debug on my machine. So let's do that. Okay. So I added but didn't actually connect. I need to type twice password because it's going through Theta and then Theta GPU. Okay, so it was quick, but while it's thinking, I probably will give you like funny stories. So we have this remote UI and install it on Linux. Everything works fine, and then we just install it on Darwin as application. And we started on Darwin and set up like a session and said, okay, let's connect. And first thing we note, there is no Xterm. So in Darwin, the application is started without Xterm, and there was no way to put password. So we have to actually start creating our own Xterm to start inside TotalView. But if you want to use it on Darwin And if you have Mac laptop, you still can do it, but you need to start TotalView from the terminal. You need to start the terminal and then find the path to application and so on. So if you want to do it, I will show you in the head-ons, and so it's still possible. And now let's see, command line here. It looks like it's connected, so it's at Linux x86 64, but I can actually see. You can type some command like execute uname -a, and I'm on theta GPU SN1. So now TotalView started connected to front end and waiting to basically to job. And I can actually on the terminal I can I always forget how it's worked. Okay, so I can go here and cd to my directory and do qsub and submit job and then connect to it. But I will do a little different now. So I have already TV Connect set GPU job. So in this job, if you can see it here, the only difference is TV Connect in front of TV CUDA matmal, and once it's started, it will let front end know the job is ready, and TotalView will connect automatically to that. Also note there is modulo TotalView, so it should find it here. But if you don't want, and if you install it locally, you can just put a full name. But there is other way to do it, and in the debugger on my front end, I can just put here a command command like qsub and just give this a name and wait here without even logging to my remote node because I already know my qsub. So let me connect again. It's really much faster if you don't need to type password 2 times. So I think it's waiting for location. Yeah, so it's starting. Okay, so you see it start running and post my question, do I want to attach? And it actually show me what job is trying to attach. I can actually do a little more advanced stuff here. I can submit a number of jobs. I can submit 10 jobs, for example, and wait with one UI. And as soon as something is ready, it will post question, and I can attach to this job or reject. I can attach to many jobs at once. So, and if you have multiple jobs, like with different size, it's really handy to attach to the one that is ready. Okay, so this is CUDA MPI job, and I can now debug on my laptop. And I can start debugging with CPU. And you can see there is local variables here and data view that I can move and see. But also, if I want to debug more, I can go directly to kernel. Notice difference, there is no line numbers available, which means that the kernel is not loaded and TotalView doesn't know, actually any debugger doesn't know where the line number is. But I can set a breakpoint in any one, it will be hollow, which means it's pending. So as soon as job start, debugger will stop at this point. So I'll just type run, and you can see it's loaded and started. And if I go to GPU status view, it shows me already that there is lanes 4. There is only 4 lanes, so it's like small size one. And if I want to go to data view, I can do next and move my application. Oh, I didn't focus right. Okay. And now I can move. If you have a big display, you can undock window, which make it a little easier. So I move row and columns, which should be different for every thread. And now I can change focus on top level. And I already know there is 4 lines, so I can change, lane. And you can see there is 1 now, column 1. So switching between different lanes, I can focus on particular CUDA thread and see the values there. So once you're done, you can unset all breakpoints and continue on CPU. Okay, any questions so far? Okay, let's move on. And if you want, you can rearrange windows also, so it's all dockable. You can dock it here somewhere. And if you want reset them again, there is very nice reset button. So it reset everything back. Okay, let me move back to reverse debugging. And so this is another dimension of debugging, and this is how TotalView is different. We work together with our partner, which is Undo Technologies, and we combine their technology and ours in one product, which allows you to actually debug moving backwards. So usually debugger move always forward, and it's not moving backward, it's basically record every history and then investigate and see how it works, how it worked before. So think of it like, I don't know, DVD player, and you record everything and then you came to crash. You want to see what happens before. You don't want to see what happens now, you know. You have a crash or you have problems. But you want to see exactly back in time when this program happens. And this is the idea behind reverse engine and reverse technology. So I can step inside. Let me just go slide. So you can step forward, you can step inside, but then you can always go backwards as well. So you run backwards for breakpoints, you can set a watch point and run backwards to watch point. So it's a whole new dimension. So this is basically how people say the right way to debug. So you came to a problem and then go back. So for each forward functionality, there is backwards functionality. So you can run forward, back forward, advance and back forward, but there is also 3 additional buttons here. First is advance to live session. So you can go backwards, but any point of time you can just click live, and this is where you stopped, and continue live execution. Because remember, everything backwards is recorded. And you can go backwards and you can go forward in recorded history. So like you are moving in DVR and back and forth, and then you go live and move again the application. Another one is create a bookmark. So you can create a bookmark, it's like a book. So if you like this point and you want to go back in future, create bookmark and then just jump to this one. And the last one, but not the least, save the recording session. So if you want to save the session and continue debugging, for example, tomorrow, you can save this session, then load it again tomorrow, and then continue debugging back and forth. So you can actually run your program till the end. And if there's no crash, but there is like some bad data, there is problems, you can save it, and you can move it even to another machine, load it, and investigate. It's like very advanced core file. Okay, and probably just one slide about memory debugging. I don't have time. There is probably video also on our website. There is like hundreds of videos, so something definitely. But what I want to mention is that we used to have a separate product which was called MemoryScape, which was only for memory debugging because it was very popular. Now we are merging it to inside TotalView, so we merge most basic functionality and probably the most used functionality like memory leaks and heap status view, so you can enable memory debugging and then detect free, delete, misuse, buffer overruns, and everything. So, and also you can use it for MPI debugging and remote, so it's not only for serial. Another relatively new feature is mixed debugging, mixed language debugging. So what we will do for that mode of operation, we filter out basically all glue code which you don't need. So, and usually, I don't know if you try to do mixed Python, C++ debugging and usual debugger, you will see there is a lot of glue code between lines, and we can filter out everything. And this is one advantage. And second advantage, we show you local variables for Python. The only restriction, you cannot change them unlike C++, but at least you can see and compare variables as they moved from Python to C++. Yeah, there is also a video here. It's definitely worth watching. We also can utilize reverse debugging and memory debugging, but again, it's not pure Python debugging yet. But this is debugging for mixed code, but I think in future we'll have Python debugger as well. Okay, so now I was talking about different technologies, and so you can use one of them, but it's really beneficial to use and combine multiple. And this also depends on what kind of bugs you're looking for, or you try to fix, and what kind of application you're using. Sometimes you combine memory debugging with source debugging, obviously. Sometimes you combine reverse debugging. To give you an example, if you have multi-threaded application and you have a mutex problem, probably a very easy way to fix this problem is to create a watch point on mutex after you find problem, and then run backwards to the last time the mutex was triggered. And also combining the multiple technology examples would be mixing reverse debugging, memory debugging, and use remote UI. So probably you won't be able to use all feature, even I guess. I don't know all feature of TotalView, so it's not expected from you, but if you start learning your feature, the more you see, probably the more feature you will choose which one you like and which one is really convenient for you and helpful. Okay, so another functionality that probably I also have a couple of minutes to talk about, that you can attach and detach from a parallel job. So if you're running the application and there is no problems that you can see, but it's running a very long time and you're really unhappy about that, you can attach to this application and stop it. And you can just inspect where it's running and whether the data makes sense. And once you check your application, you can detach and let it run again. So you don't need to kill it. You just attach, inspect, and detach. Also, you can attach to subset of your application. If your application is really huge, you can attach to like subset and see where it's going and what's going on. And also, TotalView allows you to attach to a starter, and it will attach to all of that. Okay, so I'm running out of time, and I'll just show last slide, a couple of slides that I sent you slides, so there is instructions how to use labs for head-ons. So I basically highly recommend you to, if you want to try examples, first 2 labs. Optional lab for MPI. We had some problems and we have some tricks how to resolve it, so I can help you with that, but definitely bonus lab on Theta GPU. So you can try on GPU, it's there. Okay, so our website, TotalView.io, and if you have any questions, I'm ready to answer.
What's the status on AMD CPUs?
AMD CPUs?
Yeah, so I'm particularly interested in like working on systems like Crusher, the Frontier prototype.
I know this supports AMD, and we don't have any problems with AMD as compared to Intel because we kind of higher level a little bit. On Frontier, we definitely worked. The only problem may arise from and actually I'm talking about CPU in general. So if you're talking about newest instruction sets, TotalView will support them definitely, but Replay Engine maybe lag behind because they are going deep into each operation and we are not relying on them. Even so, we show you instruction level support. And okay, something I also forget to mention, sorry. If you're a student, we have free program for students. While you're in the university, you can get free license and install on your laptop. Thank you.
Thank you, Nikolay.